All right, so real quick, we're just going to go over a couple examples using logarithmic functions, and the most famous is going to be the pH scale. So the pH scale ranges from 1 to basically 14, okay? And I've heard of other pHs, but we're going to keep this simple. 1 to 14 is going to be your pH scale, with 7 being what we consider neutral. 1 would be acidic. 14 would be basic, okay? And by definition, pH is equal to the negative log of what we call the hydronium or hydronium ion concentration, all right? I think the easiest way just to say this is just the hydrogen ion concentration, okay? So without getting too far into chemistry, basically what happens is when you have a substance that dissociates in the water, it's going to create some sort of pH. If you have something that is very strong, in other words, it's ionic and it completely dissociates, you're going to have a very strong acid or very strong base. But if you have something that doesn't completely break down, then you're going to have something that's in between 1 and 14, and we call it a weak acid or a weak base, okay? So you want to get really technical with this, please go talk to somebody in chemistry. But basically, that's the gist of this. So I do want to write down just a I guess it's a property. If the hydronium, I'm going to just say hydrogen because I know it's called something else, but I can't remember. If the hydrogen concentration is equal to 10 to the negative fourth molarity, I think it's molarity. Yeah, moles per liter. Moles per liter. Then the pH will be the negative log base 10 of 10 to the negative fourth, which is a negative 4 or just 4. So we're going to basically model all of our examples off of this simple one, okay? So here's our first example. The hydrogen ion concentration is equal to 3.16 times 10 to the negative 8th. Find the pH for that. So all we really have to do here is just follow that model that we just did. We know pH is equal to the negative log base 10 of the hydrogen ion concentration. So this is going to be the negative log of 3.16 times 10 to the negative 8, which is approximately 7.5. So we would consider this neutral. And I think this is about what your pH is for your blood. I think that's what that is. All right. Now, another example would be something like, and I'm going to, this one's actually kind of interesting. Scotland had some acidic rain once, and its pH was 2.4. I mean, that's like, that's crazy. It's like, it's almost battery acid. Battery acid it has a pH of 1. So this is like really just bad. But anyways, let's find the hydrogen ion concentration for this. Okay, so once again, we're going to use this. We know that pH is equal to the negative log of the hydronium ion concentration. So what I'm going to do is I'm going to try to isolate the H plus. All right. So the first thing I'm going to do is multiply both sides by a negative. Okay. And then from here, I'm going to raise both sides. I'm going to exponentiate both sides with a base of 10. And by doing that, remember, there's that one property, A to the log of a of x equals x. As long as these match, you can simplify it. So even though we write log, remember this is log base 10. Since these match, it basically cancels itself out. And what we've just found is a formula that will determine the hydrogen ion concentration. So 10 to the negative 2.4 is approximately 4.0 times 10 to the negative third, which would equal the hydrogen ion concentration. So once again, it's just a matter of just using our properties for logs to go back and forth, all right? The last problem that I'm going to do here deals with the Richter scale. Now, the Richter scale is used to measure earthquakes. And the Richter scale is really interesting because it does use logs, but it really puts into perspective basically how this is measured. So first, the magnitude of an earthquake is given by M equals the log of I over S, okay? I is equal to the intensity and S is equal to the intensity of a standard earthquake. Now, what's happening here is, I think, the scientist was named Richter, and he was measuring vibrations of the ground, okay? And as the ground shakes, you get all these different types of, like little up and down motions here. And then if it goes real crazy like this right here, we know an earthquake happened, okay? So this is a logarithmic scale. And what's crazy about this is if you have an earthquake, and let's say the magnitude equaled 1, all right? That is a powerful earthquake nonetheless, okay? You'll feel it shake, but I don't think anything's really going to happen. But if you have an earthquake that's a magnitude of 2, that is 10 times more powerful than a magnitude of 1. And if you have a magnitude of 3, then that is 100 times more powerful. So every time you get a new magnitude, you are multiplying this by 10 every single time, all right? So the example that I want to go over is we're going to find the magnitude of an earthquake that has an intensity of 3.75 on the Richter scale. All right, so here's what happens. If you've ever seen a Richter scale, it's just like a sliding piece of paper with a needle on it, okay? And as the paper slides, you're gonna have this little needle, and it kind of just measures all these like little vibrations that I'm drawing here. It's kind of hard to see, but you'll see them. And then all of a sudden, you may have this big jump right here. Well, the measurement of that peak is 3.75 centimeters. So that amplitude, that peak, we can use to actually figure out the magnitude of this earthquake. Now, what we're going to need, the magnitude is going to equal the log of I over S. So we know what the intensity is. The intensity is that amplitude, 3.75, okay? It's the standard earthquake that we're concerned with. So Richter figured out that 10 to the negative 4 is basically the standard of what the ground is vibrating at. So S will always be 10 to the negative 4. And if we just take the log of 3.75 over 10 to the negative 4, we're going to get approximately 4.6 magnitude, which is a very powerful earthquake. It is 1,000 times more powerful than just a regular Richter scale of 1. That's why, like, when you hear about these big earthquakes out in the ocean, some of them are crazy. They're like a magnitude of 7 or 8, and that is just unbelievably powerful. Thank God, like, nothing like that's ever happened around here for us. All right. But that's basically it here. So just make sure that you're just substituting correctly. A lot of these are just, plug and chug. If we were in a calculus course, then we would actually be deriving all these formulas that we have. So good luck this week, and got any questions, just let me know. See ya.